So here we have the function f of x is equal to y1. That's where we're going to put it, is in y1. And I actually already still have it in here from last class. So if you don't have it in there, you need to type it into your y1 equals on your calculator. And the questions that we're trying to ask are, what is the domain and range and then we'll also talk about some other things that will help us be prepared as we move forward, because this is a quadratic function, so we're going to need to be able to learn how to do some other things with a quadratic function in the next section. So I'm going to go ahead and try to give you an overview of that here. So when we do domain and range, we're looking first of all, what do we think that the x values could be? And when we're looking at what could they be, remember we have two things we can't do. So the two things that we cannot do is we cannot divide by 0, and we cannot take square roots or fourth roots or sixth roots of negative numbers. What we see that f of x's job is f of x takes whatever you give it, which is x, it squares it, and it multiplies it by 2. Then it also multiplies whatever you give it for x by 5. And then it adds that to the first answer. And then from that total answer, it subtracts 12. So nothing in here, all y is doing is it's squaring and multiplying and adding and subtracting. It never does this. It never does this. So we don't have to worry about what we call domain restrictions. When we know this is true, we know that the domain is all real numbers. And we don't need a calculator to tell us that, although the calculator will verify that for us. Now, to find out the range, you need to keep out that the range is all the possible y values. And we may have a restriction on what the range is. So what we want to do to find that, we're going to first try graphing this on a relatively small window. So we're going to go zoom, and we're going to choose number 6, which is the standard window.
What do? You graph it? Or we have that equation in there. What do you want to do next?
We want to hit the zoom button.
Alright, standard.
And then standard, number 6, standard. And what your standard window is x is equal to or less than 10 is equal to or less than negative 10, and y is also equal to or is negative 10 is equal to or less than y is also equal to or less than positive 10. So that when you hit zoom standard, that's how you're setting your graphing window up. Okay? And that isn't necessarily the window that we're going to stop on. That's not necessarily the window we need, because we're not seeing a complete graph of the function. We can see that this function does, like this domain says, it continues on, up, and out on both sides to infinity. So the top of the y values in this case also is going to be to infinity. But the thing is, looking at it here, we know we're not seeing the bottom of that graph. The because I know there's still something. This is the same graph, therefore there must be something down below there I'm not seeing that's connecting things up. Okay? So what I want to do is I want to go down and...
Isn't that when you... Oh, okay, you're going up. Your infinity's going to be because your parabola's open.
Yeah, because it's opening up.
Okay. Sorry.
Continue, it's taken off for the sky. But now I know that I can't see the bottom of it, so I need to reduce my x minimum value from -10 to something more negative than that.
20.
And 20 would be good. Anything, actually what I want to do is I want to consider this. Because that number is -12, what that tells me is that if I plug in x equals 0, that f of 0 is going to be -12, so I need to go down to at least -12. Okay? But 20 might be a better idea. Now, for some functions, 20 wouldn't be far enough. So always try to figure out by looking at your graph and at your function what the y-intercept is. So the y-intercept on this is -12. I think we might need to go to -20. So I'm going to change that to -20. And then we'll graph it again. And now I can see the bottom of the parabola. Okay? So the actual range of this function begins somewhere at some negative y value that's at the very bottom of that parabola. So I'm going to try to summarize our steps as we go through here. So when we change that window, this is kind of what we see. And we know this point right here is 0, -12 because of that. But we also know that that is not the bottommost value for the parabola. That's not going to give me my range value. To find my range value that is at the bottom, I need to find the point that's at the very bottom of what we call the vertex of the parabola. And I can't tell what that vertex is just looking at it. But my calculator will find it for me. Because if I hit alpha, or if I hit second and trace, one of the things that it will find is what's called a minimum value. So choice number 3 is minimum. And that minimum will tell me what the vertex is. So I'm going to choose the minimum. Notice that it asks you first thing, what is the left bound? What it's telling you is get to the left of the point you want me to find. So you press your left arrow until you are to the left of that point. And then you hit enter. Then it says right bound. So you press your right arrow key until you are past the point that you want it to find. And you press enter. And you check at the top to make sure that those two little arrows point toward each other, because that's the edges of where it's going to look. So now it wants to guess, and of course that's what we want it to do, so we just say yes, go ahead. And it thinks for a minute, comes back and says the vertex is at x is -1.25, and y is at negative 15.125. And that tells me this point right here, this y value, is negative 15.25, and therefore that tells me that that's the bottom of my range. That's the lowest value in my range. That's all the range values. And they continue up to positive infinity. They just keep going and going and going. But they end at negative 15.125. So when I write my range then, I begin it at the bottom, just like for the x's you begin at the left.
And I start with the smallest negative numbers.
Exactly.
To the bigger.
You always start small and go big. Remember, it's the same way that you read. You read from left to right. So now we have found both the domain and the range for that graph. And that was what we concluded that the domain and range was yesterday, except I told you then that negative 15 was our best guess from a table. Okay? It's our best guess from a table. But now we found what it is exactly without the table. So this is actually the correct range. Now if we go to the table, there is a way to actually see that happen. What we want to do is we want to set our table up to ask.
I can get to that menu.
You hit second and window.
And that's to do what?
That's to set up your table,
To do what?
to find the table of values. So first you go to table setup, and you go down and change independent, which is your X, from auto to ask. Because you want to be able to tell it what X values you want to see. Okay? So we're going to go for ask. And then we're going to go look at the table. Now, the last time we looked at the table, we started with some negative numbers and went to some positive numbers. And I just kind of arbitrarily picked negative 3. Oops, and I don't think it'll like that. Because I used a minus sign, not a negative sign. Negative 3, negative 2, negative 1, 0, 1, 2, 3. And the reason that we thought maybe that the bottom was negative 15 was because that was the lowest number that we saw here. But we can't be sure. So what we do is we go back up here and we try to go a little bit closer in between negative 2 and 0. So maybe I'll go negative 2. Let's see, well, I don't want to go as far as negative 2. I already know that. How about we go negative 1.5, negative 1.6, negative 1.7, negative 1.8, negative 1.9, negative 1.10 would be place. Negative 1.1. And we see what's happening there is it's getting closer and closer to 15. So maybe we need to try negative 1.2. Let me see if I can put these in order. Negative 1.4, negative 1.3. Negative 1.2. Negative 1.1. Negative 0.9. Negative 0.8. So right now it looks like it's somewhere between 1.3 and 1.2 because those both have the same value. So something else must be between 1.3 and 1.2. So let me go negative 1.25 and see what happens.
It should be it, because that's your upspout.
That's getting really, really close. Now, since we've already used, let me just delete these out. Since we've already actually used the graph's ability to find it numerically, what we're going to do now is we're just going to verify. So far, all we've seen was that the lowest it ever went was negative 15.12. Okay? But if we enter in the x value that the calculator told us here, negative 1.25, we see that it actually rounds the answer up to negative 1.53. The thing to keep in mind, though, is that it didn't come out to be exactly negative 15.13. It came out to be exactly negative 15.125. What you see up there in the table is the rounded to 2 decimal places version of the correct answer. So one of the things you need to learn about your table, and you need to know this next semester as well, is that you're going to see things in that Y part of the table that have been rounded off sometimes. Because that part of the table can only show you 5 characters in 1 decimal. 5 symbols in 1 decimal. So if the answer actually had 6 symbols, which is 1, 2, 3, 4, 5, 6, it can't show you that last one, so it rounds off. So the table is a good way to estimate where the minimum value is, but it's not a good way to find the actual minimum. Now there's a couple other things that we can do with quadratic equations, but we're going to talk about those in the next section. So we kind of got started in, leave that equation in your calculator, and let's look at the other domain and range problems. So we can be finished with section 1. Here we have an isolated set of pairs. We have a set of ordered pairs. There is no line connecting those pairs, which tells me then that my domain values, since the ordered pairs always go domain, then range, that tells me all of my domain values are the first coordinate of that ordered pair. So that means my domain for this function is negative 2, negative 1, 0, 1, 2. Points, rather than using parentheses or anything else.
What you do if it's just a set of points is use what are called curly braces. That indicates to you that the domain is a list of certain distinct x values and not anything in between those values. And then you get the range the same way, knowing that your range is your second coordinate.
So the range is going to be 4, 1, 0, 1, 4. And since I've already written down 1 and 4 for these 2 points, I don't need to write them down twice. So the range list is shorter than the domain list. And you saw that that was true in the last one we looked at too, because the range went from negative infinity to infinity, but, I'm sorry, the domain went from negative infinity to infinity, but the range did not go to negative infinity. It didn't begin until it got to be negative 15.125. Okay, so your range can always have a smaller set than what the domain does.
So you just basically don't have to repeat numbers.
And you don't have to repeat numbers. That's just a waste of your time and energy. Okay? Now we're going to talk about the best way to evaluate functions. When we evaluate functions, what we are saying is take whatever is in the parentheses and put it into the function. So in this case, if we're trying to find g of 3, what we're actually going to do is every place in g that we saw in x, we're going to replace x with 3. And then you just go ahead and do the math. Now keep in mind what happens here, since x is positive 3, the only thing the square is on is 3 is 9, and then you keep that negative sign.
And then 4 times 3 is 12. And the minus 5 just sits out there and rides along. So negative 9 plus 12 is positive 3 minus 5. And positive 3 minus 5 is negative 2. So your answer is that g of 3 is equal to negative 2. Okay? We're really not doing anything different when we find g of a, except that in some ways we're going to take a and in for x. That's all we're going to do. And since we don't actually have a number for a, then we can't do anything else with it. We're done. Now it is a little bit trickier when they give you an expression rather than a single variable. For example, if they give us g of x plus h, that means we're going to put x plus h in where we see x, and that means we're going to need to use some parentheses. So negative, in place of x, we have x plus h squared plus 4x plus h minus 5. And at that point, we're not done because we need to simplify that. This is something that you are going to see in the very first section, the very first chapter in calculus next semester. We are going to do something called a difference quotient, and this is going to be where we begin. So it's important you remember how to do this. So remember that the quantity plus h squared is actually x plus h times x plus h. Please try to burn it into your brain that x plus h squared does not equal x squared plus h squared.
squared plus 2h.
That's right. X plus x is in fact x squared, and h plus h times h is in fact h squared. But x times h and x times h added together is going to give you 2xh in the middle of that. So be sure you multiply properly.
What do you do with that negative sign?
Then you distribute your negative sign. So that's going to be the opposite of x squared, so that'll be negative x squared. And the opposite of 2x plus h, which is negative 2xh. And the opposite of h squared, which is subtract h squared. And then 4 times x plus h is 4x. And 4 times h is 4h minus 5. And you cannot collect any like terms because there aren't any like terms. So you have to write out that whole thing. Okay?
And then part G, two over R is equal to, and again, we're just replacing x up here with 2 over R. But you be sure and put that 2 over R in parentheses because it's a fraction and you need to remember it's a fraction.
Is that D?
Yeah, this
2
is
over R?
2 over R, that's D.
And how do you do that?
You say G of 2 over R is equal to the opposite of 2 over R squared plus 4 times 2 over R minus 5. And then you remember that 2 over R squared is 2 over R times 2 over R, and 2 times 2 is 4, and R times R is R squared, and the negative sign in front stays. Plus,
So that's 4R,
4
over
R squared.
Negative 4 over R.
Right, then you put the negative in front. So this is how we got that. And then 4 times 2R, or 2 over R. Remember when you're multiplying fractions, if you've got a whole number, put it over 1 so you multiply correctly. That's going to be 4 times 2 over 1 times R. So that's going to be 8 over R. And then that's minus 5. So that's G of R over 2. Now the last one's a little bit more difficult. And you probably have had this situation before, but you may not remember how you do it. Find all the values of g of x such that g of x equals negative 12. So what we're going to do is we're going to come back up here to our example, and we're going to choose g of x to be negative 12. And that means then we need to find out what x makes that true. So what we have then is we've got an equation to solve that says negative 12 equals negative x squared plus 4x minus 5.
Negative x squared.
That's the original expression, except g of x is now 12. And I know that when you were in 1100, you learned how to solve quadratic equations. Because that's what this is. This is a quadratic equation. And the first thing you have to do to solve a quadratic equation we have to set it equal to 0 and solve for x. So when I set it equal to 0, I'm going to put plus 12 on both sides, which starts out with this being 0, is equal to negative x squared plus 4x, and negative 5 plus 12 is plus 7. One of the ways you would have learned how to solve that quadratic equation for x would have been factoring. But that won't work because this does not factor. No matter how you turn it around, it does not factor, period. So what we'll have to use instead is the quadratic formula. And in that quadratic formula, a is the coefficient of the x squared term, so a is negative 1. b is the coefficient of the second term, the x term, so b is equal to 4. c is equal to the constant term, which is 7. And the quadratic formula says x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, and that whole thing is divided by 2a. Since I've run out of paper, I'm going to slide another piece of paper under here so I don't write on the overhead. So that means that our actual formula to solve is x is equal to 4 plus or minus the square root of 4 squared minus 4 times negative 1 times 7. And that's all going to be divided by 2 times negative 1. And since the most complicated part of the math is going to be the part under the radical, we'll go ahead and do that part first. Now you can use your calculator. I'm going to attempt to do this in my head. Okay? We'll see how well I do. 4 squared is 16. Negative 4 times negative 1 is positive 4 times 7 is positive 28. And 16 plus 28 is 44. So this is 44. Now there's actually 2 different ways to get the answer. If my math lab says give an exact answer, then you say that x is equal to -4 plus the square root of 44 over -2.
Isn't that plus or minus?
It is. And the minus then says take -4 minus the square root of 44 over -2. Now, I don't know if they taught you this in 1100 or not. It's been a while since I taught 1100, but one of the things that sometimes my math club expects you to do is called simplify the radical. Pull the 4 out. And because you can actually take the square root of 4, when you take it outside the radical, it becomes 2. But the 11 has to stay inside the radical. Now this is called simplifying the radical. So there's your 2 answers, but it's still not completely simplified. Much as you want to think it is, and I want to think it is, it's still not completely simplified. Because this -2 will divide into both -4 and +2. So you're going to have to factor out a -2 in the numerator.
I get really, really confused right there because I've had people tell me different. That 2 is connected to that 11.
By
So
multiplication.
it's almost like if you're saying x squared plus 8b, you can't put the 2 together because they're not the same.
You can't put them together algebraically, but
Because you're reducing because they go into all 3.
yeah, hang on and I'll show you. What I'm doing is I'm factoring, and I'm kind of treating,
Because that 2 is with that 11.
that is.
So you can't
But
touch it, right?
think of that -11. I can touch the 2, just like that was, let's suppose that actually said that that was 2x. Minus 2x plus 2x. Well, yes, I can factor out -2. -2 times +2 gives me 4. -2 times -1 gives me +2. And I just keep that square root of 11 right where it's at. It's just like a variable. Same thing on this side. -2 times 2 and -2 times +1 square root of 11. So what that lets me do in the end is it lets me factor out the -2, and there are my final 2 answers. 2 minus the square root of 11, 2 plus the square root of 11. So the 2 values of x, and that is a 1. It looks like an I, so let me kind of straighten that up. So there's your 2 answers, and that's the exact answers. Now, if my math lab says exact, that's probably what it wants. However, before you, since you get 2 tries before it tells you nah, trying a problem, I thought you did 3. It may let you put in that
On the,
on my math lab. It may let you put in the unsimplified version, and that would be fine. If you want the exact version, that's what you have to do. However, for me, we would plug that into the calculator and get decimals.
on the final, are you going with the exact or simplified?
I'm probably going to tell you to give you the decimals. Because in real life, if this was a problem where we needed to know what number of units would produce a negative profit of $12. We don't want to know that radical stuff, we want a number, okay? I will see you next week. I will send out a message in Shelby, giving you some times that I can do reviews and see who can sign up for when.
Hey, thanks for doing that.
No problem. I think not. I was so proud of you when I did that. I thought, oh my gosh, he's going to be so happy.
It helps a lot.
I can tell you it really, really stuck.